Hello and welcome to Crazy Danish Hacker. Today we're going to look more into accessing this hidden serial consoles. So here we have the TP-Link router again. And we also have a multimeter, the oscilloscope, and we are going to plug in the power. So the first thing that we will start with is that we are going to start with the multimeter. Set it to 20 volt and then DC, that's the flat line. This one is AC, so you want the flat line because it's using DC. So since I already know which ports are which, it's probably going to be a lot easier. So we have power here and we have this one here. So this one is 3.3, that's the transmission port. And this one is the receiving port. So this one goes up to 3.3 volts depending on when it's receiving. So when it's receiving it goes up, but you can't see that with the multimeter because it's way too slow. But in this case it's good enough for us because that way we know that this one is for receiving. This one is for transmitting, and this one is the ground. This third one. There's nothing here. And you can see if we turn them around, it would say minus. So that way we know that it's the wrong way around. So you can see minus, minus, and nothing. And I think if we turn it on while it's booting up, we might have some voltage going from the voltage to ground. So we'll just try again. Nothing. Anyway, it's a good way to make sure that you're not connecting to the wrong circuit, for example. But in any case, at least now we know which pins are which, most likely. So we have, power, ground, and the TX or RX and TX ports. So the interesting thing now is that we can use an oscilloscope or oscilloscope. I should probably find out how it's properly pronounced, so don't keep on saying it twice to find out which one is the right one. I think it's oscilloscope. Anyway, we have the power here. And let's just run it so we can run it. Is it running? It should show something, but it's not. Because usually it shows, that something is going on. But nothing is happening at the moment. Alright. So it looks like it was because I was using a USB hub and it didn't like the USB hub. So now I have no keyboard, but at least I got the camera, the second camera, which is not USB, and we got the microphone, which is right here. And we got the mouse still, and we also got the oscilloscope. So let's try and run it. So this is how it looks like when it's just running by itself. And if we touch them together, they should provide like less noise. Now I'm just touching one of them, so you can see that it's passing through my body and it's making a little bit of a difference. Compared to now, it's almost nothing. So let's try and connect it to the voltage pin right here. And maybe set it to 5. So it's updating slower. And we can try and touch the ground pin first, just to show you that nothing is happening. I'm just going to put it further down. So we are just going to put this on the ground pin first. So you can see nothing is really happening, or it is. Just make sure you're not touching the other wires at the same time, because otherwise you're going to have inaccurate data. So the ground wire shouldn't really do much. So if we take a look at the TX wire, you can see that it's just a continuous signal, but you can see that it jumped from here to here. So that's a good indicator that it's connected the right way as well, because if we're connecting the red and black wire the other way around, it will go down instead, so it'll be minus. So the next cool thing that I saw the other day, which is actually the point of this video, is to show you that you can confirm that it actually is receiving data. So if we connect it here, and now nothing is happening by the looks of it. But if we power off the device, this is how it looks like when it's powered off. If I unplug the power supply, you can see this is without any power at all. So you can see there's a difference even when you just plug in the power supply. A tiny bit, but a tiny bit is something, so that's quite interesting. So watch what happens when I turn on the device. So these spikes that you see, those are actually data. So that's the cool part. So if we take a very fast updating timing like thing, then take a look again. And stop, and history, zoom in, and here you can see it a bit more clear. So it's still a bit unclear still, as you can see it's not perfect, but it does show some, some differences. But we can do better than this. We just have to try again. So we set it to 0.1, and then we turn it off, turn it on again. And wait a bit, there we go. That's the signal that I was looking for. So here, now you can see it much more clearly. So that's actually quite cool, That's the whole thing, well, one of the things that I wanted to show you. To show you what it looks like when you're looking at the data in another form, basically. So this is how the data looks like when it's being transmitted over USB back to the computer with this device. So that's actually, I think that's very cool. So you can see, like, it might look random, but it's not. Like, you can see this one is bigger. So this might be a 1, and this might be a 0. So it's like 1, 0, 1, 0, 1, 0, 1, 0, and so forth. And as you can see over here, it's maybe 1, 0, 0, 0. It could be, I'm not sure. So that's pretty cool. I haven't looked up like this yet as to how to, for example, decode what this is exactly. But you could probably manage or figure it out if you really wanted to. But it's quite cool because you can see that the pattern repeats. So it's not like there's not a pattern. There's definitely a pattern. And you could probably, if you set it to 0.5, you could probably make it look even better maybe. That was not the point. Okay, let's try again then. It's not, it's a bit hard. It doesn't save immediately, so sometimes it's a good idea just to let it run a bit. And here we can see the same signal again, but in a more extreme version. So we have a little bit more detail, but yeah, we need like 0.005 or 0.5 ms to get an even more clear signal, I guess, but this device doesn't support that. I think I'm a noob at this anyway, but I think it's very cool that you can look at this and you can see that these are actually computer signals. So that's very cool, I think. So there are some other things for this program that you can use, but to visualize this data, it seems that the oscilloscope is basically the best way to do it. So I think that's pretty cool. That's basically that for this video. In the next video, we are going to hook it up with the device and look at the actual serial console output. So that would be very cool as well. Stay tuned and subscribe.